Welcome back. Today on the bench, we have a Hovercraft Caribou. Don't know what's going on with this guy. Blew a fuse, got brought in, found the fuse that was blown. I'll show you which one it was. We are going to do kind of a just general checkout to make sure it's nothing inside the amp that blew the fuse. I did power it on after that at full power. Seemed okay. No schematic for this guy. These are kind of not super common, made in Portland. I think now a defunct brand. I'm not sure if they're still making amps. Don't have the head shell. The customer kept the head shell. They're building a new one for this or something. But yeah, I'm going to kind of just walk through a procedure I would do in exactly this situation as I do it, to kind of check out when you don't have a schematic. You need to check out an amp. It's got relatively common components. We got a couple 12AX7s, probably a phase inverter. So this is probably preamp stages for the channel 1 and 2. Two EL34s. We've got our power transformer. We have our output transformer. We have a choke. Amp's an amp. Yeah, it looks like this guy is a 2-channel amp. Just a volume for channel 1, maybe a shared, although it's just on channel 2. There's a contour and gain, so maybe this is just like a clean kind of setting. Looks like we probably have relays for our channel switching, and then a shared presence and tone stack. Yeah, not too much to it. I'll show you the back panel. These are cool amps by all accounts. I've never actually played one, but I've heard great things. Not sure why they quit making them. Yeah, let's flip it around, see what we got going on the rear panel. Okay, rear panel. We've got a foot switch for probably channel switching. Individual outputs. Nice little note, put amp on standby before switching. Great advice. So you got some options there. There's a vintage modern power voice, which is a variable knob. Depth, which is the same. We've got a tweed switch. Oftentimes this tweed switch bypasses the tone stack, so you get a little bit of extra grit along with a volume boost. Not 100% sure that's what's going on in here, but that's a really common Fender style circuit mod. High power and low power, so probably switching your power tubes from pentode to triode mode. Again, kind of a common mod in amps. Marshall did this a lot in later like 90s amps. We have a fuse here for the high tension fuse, so that's usually for your B+. And then this, the customer actually got in here and checked the fuses. They knew enough to check for those, but this one is the one they missed. So inside here, if you take a little flathead screwdriver, you can pull this out, and there is a smaller fuse in there, an AMG style, the 5mm by 20mm style, 3.15 amp fuse, fast blow, right in here. And they're actually, I don't keep these in stock, but when I pulled that out, there was an extra one in there. There's a space for an extra. So pretty lucky. Okay, let's take a look inside, and then we'll do a safe power up, check some voltages, see if we can find anything wrong. Okay, so it's one of these massive PCB designed boards. This is kind of what you see in a lot of the newer like Fryettes. I mean, Soldanos did a similar thing. So there's nothing wrong with this type of design by any means. A lot of people have opinions about point-to-point versus tagboard versus PCB or whatever. Well-designed amp is a well-designed amp. Doesn't matter what's going on with the construction. Nothing obvious in terms of know if one of these resistors was completely black and burned out and the other was not. That might be an obvious indicator. Nothing like that is looking crazy. Customer changed out all these fuses. We don't have any bubbling caps. Although this guy has, to the touch, a slight dome. But I don't think enough to be any kind of concern. That could just be me being sensitive to it. Doing a visual check. It doesn't... I don't know if I can get this for you guys, but it is basically flat there. It's maybe something to keep an eye on, but not a huge concern. This stuff on the bottom, this is not electrolytic fluid leaking. That's just there to secure the caps like we've seen in other amps. So that's no cause for concern. Again, we can see this is a Caribou. Yeah. A lot of glue holding things in place. So let's maybe power this guy up, measure some voltages, and we will go from there, see if anything's out of sorts. I did test the tubes already on my tube tester. They were all good. One of the 12 AX7s is a little suspect, but that wouldn't cause a fuse to blow like we saw. I think it's just slightly worn out. Now, the thing about a tube tester, a classic tube tester, can definitively tell you if a tube is bad. It cannot tell you if a tube is good. But it can tell you if it's failed open or failed short. But there is not a mutual conductance or, classic style tube tester out there that will give you a reading that says good and have it mean anything. Any of them that tell you that they do that, that's just false. Unless there's some, magic mil-spec one out there that I've never heard of. They can tell you if it's failed. They can tell you if it's failed short, failed open. But the best way, once you know that it's neither of those things, putting the tube into an amplifier so that it's not going to then hurt the amplifier or blow a fuse, you can use your ears to tell you if the tube is good or not. Okay, yeah, we'll power this up and then see what's going on. Okay, so going to power this guy on. I couldn't get my meter in a position where I can easily show you the voltages, but I'm reading DC volts. Basically what we're going to do is we're going to go through and measure the voltage at each of the pins for the tubes. You can see we've got V1 over here. We have V2. Let's see, is it hiding underneath this guy? Oh no, it's right here. This guy's V4, which is interesting because there's only the 3 tubes, so they may have used a similar board for a different amp that has a V3 in this position. And then same for our power tubes here. We're just gonna measure those voltages, see if it's something that seems relatively realistic for what we should have. We will then probably, if everything looks reasonable there, the next test would be to, I guess we can go through the chopstick, kind of poke at some things, see if the amp cuts out at all, do a little sound test. I've already gone through any of these larger resistors, measured those to see that they're within, about what they should be. These should be 1K. I got like 850 ohms or something like that. These are all in parallel with capacitors, so they get like some kind of rising value. But that's nothing's failed open or short from what I can tell. We'll also go through and bias the tubes, the power tubes, check that those are within spec. I'm not seeing anything standing out that should have caused a fuse to blow. So with a fuse blowing like that, a fuse always blows for a reason. We never want to assume that a fuse blowing means nothing. That being said, it can also be caused by things that are outside of the control of the amp. It could be caused by something like a transient at your wall voltage. If you have bad power at your house, neighbor turns on a table saw, you get a spike in your power for a second, especially with a fast blow fuse. That could have easily blown that fuse on the back, kept everything else okay, protected the amp as it should. But we always want to be wary of, you never want to put a higher size fuse in to keep it from blowing. That fuse is protecting the amp, protecting everything else. It's basically a thin piece of wire that is meant to be the best and easiest point of failure for if your current exceeds a certain amount at the known voltage. So never, take that happening lightly, but also with a test or with something like this, there is a good chance we're not going to find anything wrong in this amp. Okay, so let's power on, see what happens. Okay, so we are powered on the current limiter, mostly because I do not have another one of those fuses. So if we were to blow this fuse, I would feel really bad because it would mean this customer would have to wait an extra couple days, unless we happen to find one at the hardware store. So our voltages will be a little bit lower than expected in a different scenario if we were under full power. I'm just going to call these out since I couldn't put my meter in a place that was convenient. But right here we're getting, let's see, still warming up, but we're settling out at, so this is pin 1, this is a plate. And the tubes are still coming up to temperature. It's around 200 volts right now, 203, 204. Okay, 208.7. I am going to monitor this and make sure it doesn't keep climbing. And now this is a good test too. So this is in the Aspen Pittman book, but do we have sound coming out of the plate? I'm going to bypass my attenuator. Okay, right there. I'm not sure if you can hear that, but we're getting a pop. Let me turn this up. That right there tells us from this point forward meaning towards the power tubes and onto the speaker, we have signal. So you would go from the plate of the last point. Now this is a phase inverter, so this test is not as accurate as it otherwise could be. But 1, 2, 3, 4, 5, 6. There's our other plate, 207. And now you would work your way back. Next, going to the grids. Pin 2. Pin 7. 1, 2, 3, 4, 5, 6, 7. That one's much more quiet. And again, this is the phase inverter, so not a true version of this test. But we are getting signal going back. So now we would go to our next stage further back towards the input. 184. And you can hear we have sound at the plate. Sound at the plate. Getting a pop. Now this looks like a cold solder joint right there. So that's interesting. We are getting some sound there, but I might touch that up. And again, sound. Okay, so our plates all have voltage I would expect. .200 volts there. Okay, all good signs. We'll just check our other pins here. No real surprises. 154 for that plate. And again, this one I'm going to touch up for sure. It doesn't look bad enough to the point where things would really be bad, but definitely worth touching up over in here. Okay, so check in. This is our bias for this tube. We're getting negative 15 volts. And again, these are lower voltages. Negative 15.2. There's 261 and 260. So that's either side of the screen resistor here. Now this is coming up on the sun amp. Here's our screen resistor, one side. So if you watch that sun amp video, there were some people asking about screen resistors and voltage across them being correctly rated. So you can see right here, one side we're getting 261.2 volts. The other side, 262.2. At idle, there's 1 volt of drop across the screen resistor. So a 350 volt nominally rated resistor, and same on this guy. So a resistor here that's 5 watts are rated for 350 volts nominal, 700 volts for peak, gonna be just fine. Even if you scale this up to an amp that's using 6550s like the Sun Model T, there's no way with a healthy tube you were going to cause that resistor to blow. Okay. Things are all checking out there. I'm just going to check some other voltages. Got 262 here. And so I'm basically just looking at, again, there's no schematic for this amp that's available to me at this point. This is a power resistor next to our cap, so we should have some kind of plate voltage here. And I can see I've got 244 volts on one side and 263 on the other. Okay, this resistor is doing its job. Same deal over here. This one's a little hidden, but with the camera view. But we've got, they look like 220K resistors next to our filter caps. Very similar to an offender amp. Okay, and I'm getting 263 on one side of this one, 130 on the other, 130. So the node must be shared between the two, and 0 on the other side. So this is a voltage divider going across our filter caps, probably to give the voltage for something in the preamp. This is at 131. I'm guessing one of these guys, I think these ones were 200. But like over here, let's see. This guy's 155, 186. Yeah, so that's going towards something else in the circuit. There's a chance our channel switching, since it's relay based and we're on the current limiter, so our voltages are lower, that that relay based channel switching isn't going to work correctly. So I'll check that out at full power. Now that we know nothing's going to short out, it's okay to test at full power and see what's going on. So at this point, I'm going to hook up to the CompuBias so we can check bias. We'll bring this thing up to full power. We will check the functions of the amp. I will poke around a little bit. I actually might do the poking right now, actually, on the current limiter. So I'm going to use a chopstick, non-conductive tool, and we can kind of push around anything that's suspect. At this point, I might grab a guitar and get some signal going through this while I'm doing this and see if anything cuts out. Okay, so can't really seem to get this thing to fail, so going to power down, discharge the amp, touch up that solder joint over here that looks a little cold. In fact, I'll go ahead and power this off. And we will hook up to the bias meter, let it sit for a while I do some other work, see if anything pops up. If I start hearing some crackling or popping in the background, that could be a sign that something is failing over time, which usually if that's happening, it's something that's failing from heat. So either a resistor heating up and desoldering itself, a capacitor that's starting to fail, and that's only showing up once it has heated up to a certain temperature. But otherwise, not much we can do, outside of putting this on a cab, getting it to vibrate under heavy load to see if there's some kind of cracked solder joint somewhere. I don't see anything else that looks suspect in terms of bad solder joints. So yeah, unfortunately, this could be just a case of mystery fuse blew and got to hand it back to the customer. Usually in these cases, I don't even charge my normal bench fee. I just charge a minimum fee because, just is what it is. But this is a scenario where the customer is most likely going to need to just take the amp, play it, see if the issue comes back. And if not, then great. If yes, then I'll take a further look. Okay, so let's get to soldering and then bias up these tubes and then take another look. Before I get in there, I just wanted to show you, these never quite translate well with my camera, but this is the cold solder joint. Now, it doesn't look too dissimilar to the one next to it, but I think you can hopefully see how it's just like not grabbing that leg there. This one in person is actually shiny and coned up like it should be, whereas this guy is not grabbing onto the leg all the way. There's like a hole there, and it is dull and looks a little cracked. And that's why I'm identifying that as a cold solder joint. So I'm going to touch that up real quick. I realized I didn't get a good close-up of that, so I wanted to share that in case anyone's unfamiliar with what that looks like. Amp is on. We are monitoring the bias. Something interesting did pop up that's worth noting here. So again, with the Compu bias, you guys have maybe seen this on my channel before, but EL34 should be 12 to 18 watts. We are now at 16 and 15, which is right in that middle of that range. Could even come down a little bit. When I first fired this up under full power, these values shot up. I saw them hit about 28 and rising before I turned the power off. Now, looking at, and I'm going to be very careful here, but that round cylinder guy here, this is our bias pot. Normally there is a keyway in that, a little notch for you to insert a screwdriver and then rotate. And it is completely broken off to the point that's rounded out. And I feel like it was cranked way over too far to one side, which means the bias was running super hot in this amp. I might double check the limiting resistor. That resistor that's right behind there, R40, should limit the bias from going too hot. There's a chance that's failed. So when we power back down, I'm going to check that out. I'm otherwise going to let this just sit for a little bit and see if the bias stays nice and stable, which it is. But I actually could not find a screwdriver that would fit in the keyway as it is for that bias pot. I had to just kind of cram the end of this chopstick in there, I guess actually this side, and then through basically just pressure, rotate it into position. So I'm going to drop this back down to about probably, let's see, 14 or maybe 15 watts. It's in a 16.1 on both tubes right now. Yeah, let's see if we can get it to sit nice and stable. So once everything's warmed up, it'll settle in at around 15. And I'll check back in with you and see if anything else has popped up. Okay, so after adjusting bias, letting it sit for a little bit, played the amp for about half hour or so. It's been warming up for about an hour. Everything seems nice and stable. We have a slight difference in the dissipation of the two tubes, but nothing, I mean, we're talking about 1 milliamp causing that 1 watt difference or 0.4 watt difference. Nothing to be concerned about. Yeah, things are good and stable. It's settled into a nice midpoint for the dissipation value at rest of the bias. We've got that cold solder joint fixed up over here. I'm not seeing any reason a fuse could have blown other than if that bias was set super hot. That definitely could have done it. But yeah, I think we're going to button this guy up, hand it back to the customer, and just do a minimal fee for checking this out. And good opportunity just to see something a little different on the bench. Again, this is a Hovercraft Caribou. First one of these I've seen, in person at least. But it sounds pretty good. A little crunchy, a little fizzy, but good for some doomy stuff, if that's what you're into. And yeah, if there's one in your town, check it out if you can. Thanks again for watching, as always, and we'll see you on the next one.